Hi everyone, this is Bipin Kumar, founder of RPM Tutorials. Welcome to my channel. In today's video, I'm going to talk about moment of a force. Moment of force is defined as force multiplied by perpendicular distance of the line of action of force from the pivot point. Let's try understanding it. Suppose this is a steel rod which is pivoted at this point O. Okay. Now suppose I apply force F acting downwards here. So the line of action of force is this line. Okay. Pivot point is this. So perpendicular distance of this line of force is D. Okay. So in that case, the moment of the force is force multiplied by the perpendicular distance of the line of action of force from the pivot point. Okay. I cannot take any other distance, like I can't take this distance or this distance. It has to be perpendicular distance. Okay. This line which I have drawn is perpendicular to the line of action of force. So therefore, moment is equal to F into D, where D is the perpendicular distance of line of action of force from the pivot point. Okay. Now, as you can notice that if I apply a force here in the downward direction, the rod will have the tendency to rotate downwards. Okay. That is in the direction of the clock movement. So this will be a clockwise rotation. Okay. Now, instead of applying the force here, if I apply a force here, then what will be the tendency of this rod? To, of course, rotate in this direction, which is against the direction of rotation of clock, or it is called anti-clockwise direction. Now, the moment which is clockwise is conventionally taken as negative, and the moment which is anti-clockwise, that is taken as positive. Okay. Now, if suppose both forces are applied together, then this force will try to rotate the rod in clockwise direction, and this force will try to rotate in anti-clockwise direction. Suppose I apply one more force, like say F2, and apply a force here, F3, then even this F2 will try to rotate it in anti-clockwise direction. This F3 will also try to rotate it in the clockwise direction, right? So, when number of forces are being applied on a rod which is pivoted, then the resultant moment will be the net moment produced by all the forces. Okay. Now, if we end up in a situation where despite all these forces being applied, the rod remains horizontal. What does that mean? That means that the turning effect in the clockwise direction and turning effect in the anti-clockwise direction is equal, and therefore the rod remains straight, horizontal. Correct? This is what is called principle of moments. That the net rotational effect is zero in that case, which is kind of equilibrium condition. In that equilibrium condition, sum of the anti-clockwise moments, all these moments, for example, this one will be force multiplied with this distance. This one will be whatever be the magnitude of force multiplied with only this distance. Sum that all the moments in anti-clockwise direction. If that is equal to sum of the clockwise moments, that all the moments in the clockwise direction, then it is the rotational equilibrium condition and this is what is principle of moments. That is, sum of all the anti-clockwise moments will be equal to sum of the clockwise moments. Okay. Now let us use this concept in solving this problem. The problem is that above figure shows a meter rule. There is a meter scale which is given. So of course there will be, the divisions will be 10 centimeter divisions and up to 100 centimeter because it's a meter rule. Okay. It is pivoted at its end A. So pivot is here. Okay. So against this pivot point it can rotate. At the 0 mark, it is pivoted at the 0 mark. A force of 40 Newton. 40 Newton force is acting downward at 40 centimeter mark. At this mark, 40 Newton force is acting downward. And a force FB is acting upward at 100 centimeter mark. Okay. The meter rule stays horizontal. Same condition, that it is in equilibrium, so it is not rotating in either direction, it is remaining horizontal. Find the value of force FB if the rule is of weight 20 Newton. Its own weight is 20 Newton. The meter rule weight itself is 20 Newton. Okay. Now because the weight of the rule is 20 Newton and applying the uniformity condition, similarity condition and the center of gravity condition, the weight will be acting from the midpoint of the rule. So therefore this 20 Newton will be acting at this 50 centimeter mark, right? Now, if we apply principle of moments, then we can find out what should be the value of FB. Let's apply that. Okay, so now let us try applying the principle of moment in solving this problem. So what is the total clockwise moment? See, this force is acting downward. This is a pivot point. So it will try turning the rod in the clockwise direction. What should be its value? This is the force 40 Newton. And from the pivot point, the perpendicular distance of line of action of force is 40 Newton force. This is line of action. And from the pivot point, the perpendicular distance is 40 centimeter. So 40 by 100 meter will be the perpendicular distance. That is how we calculate moment of the force. Force multiplied by perpendicular distance of the line of action of force from the pivot point, right? What about this one, the weight of the meter rule? That will also try bringing it in this clockwise direction, right? Now, the force is 20 Newton. What is the distance of line of action of this 20 Newton force from the pivot point? This is 50 centimeter. So we can write this as 20 Newton multiplied by, this distance is 50 centimeter. So it is 50 by 100. Correct? What is the total moment in anti-clockwise direction? Total moment in anti-clockwise direction. This FB will try to rotate this rod in anti-clockwise direction. So therefore, moment produced by this force FB will be the magnitude of force FB and the perpendicular distance from the pivot to this point. From the pivot, the line of action of force is 100 centimeter. So this should be 100 by 100 meter. Correct? Now, as per the principle of moments, moment in clockwise direction must be equal to moment in anti-clockwise direction. And therefore, 40 multiplied by 40 by 100 plus 20 multiplied by 50 by 100 must be equal to FB into 100 by 100. Correct? Now, because this 100 is in denominator and this is common, so we can cancel this by this 100. And therefore, this 1600 plus 1000 is equal to FB into 100. And therefore, FB will be equal to 2600 divided by 100, which is equal to 26 Newton. So this is the force of 26 Newton which is acting upward. Okay. So with this example, it is clear that using the principle of moments for equilibrium condition, you can find what is the force which is required, which is the unknown force, and you have to find out the value of it. Right? Now let's consider a situation where the problem says that assume that this meter rule is having no weight. In that case, what will happen? This 20 Newton will vanish. So if this 20 Newton vanishes, then the moment because of that vanishes. And therefore, this part, that 1000 Newton meter, that will vanish. And therefore, your force FB will be only equal to 16 Newton. 1600 by 100, 16 Newton. So the problem can be framed in many different ways, depending upon how you use the principle of moments. As long as you have the clarity of how to use the principle of moments, you can find out any unknown force. Hope with this example, application of principle of moments is clear to you. Thank you.